While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will hopefully enhance your mathematical understanding. So welcome back to 1 Lesson 3 Math. This is the next 10 minutes, 10 marks video, and there are 4 questions for you to have a go at. If you want to have a go at them, please pause the video now before I proceed with the explanations and solutions. So question 1 says work out using written methods parts A, B and C. So first of all, part A, everybody likes a good part A. We need to do 12 times 0.3. Now I'm going to come at this question, and remember, by the way, you can always use different methods. As long as you get the right answer, it's fine, whichever method you use, as long as you show you're working out. So I'm going to do it by saying, well, I know that 12 times 3 is 36. Now 0.3 is 3/10, and 0.3 is 10 times smaller than 3. So what I'm going to do is I'm going to say, well, 12 times 0.3 therefore must be 3.6, because it's going to be 10 times smaller. The only difference between 12 times 3 and 12 times 0.3 is that we have 0.3 instead of 3, so that's 10 times smaller. My answer is going to be 10 times smaller, so it's 3.6. So 12 times 0.3 is 3.6. Now to do part B, I'm going to set it up using a fraction line, although you would never have decimals in an actual fraction. So I'm going to write 0.4 over 0.2. Now what I can do is I can use equivalence here to make this easier for myself. So I'm going to times them both by 10. So that becomes 4 over 2. It's still equal because I've times the numerator and the denominator by the same thing, 10. And 4 divided by 2, well, that's 2, obviously. Okay? Now, if you didn't want to do it that way, there's a whole lot of other ways that you could use. One of them would be to change the decimals to fractions and use the stay switch flip method. So changing those decimals to fractions, we have 4/10, 0.4, divided by 2/10, 0.2. Now that would simplify to 1/5, but I'm going to leave it as 2/10. When you've got one decimal place, you can write it over 10 and then simplify. But I mean, we only need to simplify for our final answer. So we're going to stay switch flip. First fraction stays, the divide switches to a times, and the second fraction flips. So 10 over 2. So now I can use the fnyam technique and fnyam across the top and fnyam across the bottom to multiply those fractions. So that becomes 40 over 20. 4 times 10 is 40. 10 times 2 is 20. 40 over 20. 40 divided by 20 equals 2. So there's my answer. Same answer. You can see using a different method, you come to the same solution. Now for part C, we've got 0.65 divided by 0.5. Again, I'm going to set it up using a fraction line. 0.65 over 0.5. Now, this isn't quite as straightforward as the previous question, but I can still times both of them by 10. So I've got 6.5 divided by 5, and now what I'm going to do is I'm going to use bus stop division. So 5 into 6.5, 5 goes into 6 once, remainder 1. So we put the decimal point and carry the 1. 5 into 15 goes 3 times, there's no remainder, so we've got our answer. So the answer is 1.3. Now, the other thing you might be able to do here, if you know the rule, dividing by 0.5 is the same as timesing by 2. So 0.65 times 2, well that's 1.3, or 1.30 if you're dealing in money. But 1.3 is fine for this answer. So, question 2. Hugh Gelliphant and Hugh Jamster are very big animal fans. They both did a math test. Hugh Gelliphant scored 19 out of 25 and Hugh Jamster scored 16 out of 20. Who got the better score? So first of all, I'm going to set these scores up as fractions. And then what I'm going to do is I'm going to look for the lowest common multiple of the denominator. Now the lowest common multiple of 25 and 20 is 100. So I'm going to look for the multipliers to create equivalent fractions with denominators of 100. 25 times 4 is 100, and 20 times 5 is 100. So I'm going to use times 4 top and bottom for the first fraction, times 5 top and bottom for the second fraction to find equivalent fractions that are more comparable. So 19 times 4 is 76, so it's 76 out of 100. That's what Huge Elephant got, effectively, with an equivalent fraction. And Hugh Jamster, well, 16 times 5 is 80, so that 16 out of 20 is equivalent to 80 out of 100. I'm actually going to change these to percentages now. So Hugh Elephant got 76%, and Hugh Jamster scored 80%. So quite clearly, Hugh Jamster got the better score. So that would be a suitable explanation. Remember, on these questions, you do need to show you're working out to prove who got the better score or to prove a statement correct or incorrect. So for question 3, similarly, Chris Mastery says x is greater than y for the two angles shown on the diagrams below. So we need to know our angle rules. Now, first of all, because the lines have arrows on them, that means that they are parallel lines. And when you've got angles in parallel lines, there's two main rules that we use. So the first one is for angles, and we can see here that we have the z, so x is going to equal 73 degrees because alternate angles are equal. And it's really important that you know the word alternate for this rule, and you have to write down alternate angles are equal, because the question says state the angle rules that you use. So when you've got z angles, alternate angles are equal. Now for the second diagram, we need to work out y. So we can spot the f there. We've got a fangle, and when we've got a fangle, we can say, right, first of all, y equals 116 degrees, and that's because corresponding angles are equal. So the rule there, very important, corresponding angles are equal for f angles. Now that means that we can go back to what Chris said. X is greater than y. Well, no, it's not, because 116 is greater than 73. So Chris is wrong. X is less than y. So that would be a suitable explanation for this question. I'll just move this so it's all clear. So, jumping on to question 4 now. Anaconda loves polygons and snakes. A. Anna makes the following controversial statement. Exterior angles of a polygon always add up to 180 degrees. Is she correct? Now this is a rule that you need to know. Exterior angles, the angles on the outside, always add up to 360 degrees. So obviously Anaconda is incorrect here. Exterior angles always add up to 360 degrees. You need to remember that. And for part B, we have the question, an exterior angle of a regular shape is 30 degrees. How many sides does it have? Now, regular shapes have all angles the same, all angles equal, and all sides the same. All sides are equal for regular shapes. So how many sides does this shape have? Well, if all of the angles are equal, that means each exterior angle is going to be 30 degrees. So what we can do is we can say, well, the total of exterior angles is 360 degrees. So we can do 360 divided by 30, and that gives us 12. That means it has 12 exterior angles. That means it has 12 interior angles. So therefore, it must also have 12 sides. For part C, we have to find the value of x. Now, this shape is not regular because the angles are clearly different. So what we need to do is we need to say, first of all, what shape is it? It's got 5 angles, it's got 5 sides, so it's a pentagon. What do the angles in a pentagon always add up to? Well, the angles in a pentagon always add up to 540 degrees. If you didn't know that, you could always use the formula number of sides take away 2 times by 180. N take away 2 times by 180, that would be 5, take away 2 is 3, times by 180, that would give you 540 degrees, the sum of the interior angles in a pentagon. So we'll add these angles that we have together. 134, add 170, add 96, add 90, that's 490 degrees. So therefore the other angle, well, we're going to do 540 take away 490, and that is 50 degrees. So x equals 50 degrees. So I hope that's been a helpful video. Hasta la pizza, arrivederci, so long, goodbye, ciao for now, au revoir, we will see you next time.